let's take a look at 11.1. What are the major threats to aquatic biodiversity? So what are the things that are really threatening those aquatic ecosystems that we talked about in Chapter 8? And one of those is that when we look at this, that aquatic diversity is huge. I mean, there's the whole Earth, most of it is covered in water, 71%. Is covered in oceans. I mean, the greatest marine biodiversity is located in these three places: the coral reefs, the estuaries, and the deep ocean floor. This is where species have really adapted and really have become diverse or different than all the rest of the species because of those unique habitats. And biodiversity on general is mostly near the coast. The diversity is higher near the coast than the open sea, and it's also more at the bottom than the ocean, and the top of the ocean, or the top of the water column. So that's just a general rule. Near the coast and near the bottom are really where the most diversity is occurring within those marine ecosystems. But a lot of these things that are happening is we're losing a lot of habitat. Now, I'm not thinking like, well, the oceans are still there. They're not going away. But the problem with them is that they're really being tampered with to the point where those fish that are used to those different conditions can no longer thrive there. And it's happening mostly in the coastal regions as well as the ocean floor. And we're going to talk about the effect of trawlers. And trawler is a type of netting that literally scrapes the bottom of the ocean floor to collect fish. And so we're going to take a look closer at trawlers in a little bit here, and take a look at what kind of damage they actually do. In freshwater, we're still seeing a lot of damage because of dams and diverting water and slowing the flow of water down because of dams. Changing the course of things, especially also with excessive water withdrawal. A lot of this fresh water we need to use for drinking and other things, and we're using a lot of it, almost too much of it. So those are a few of the different human activities that are kind of destroying those aquatic ecosystems. This is just a quick look at how a before and after picture of a bottom trawler. The bottom trawler nets, the trawl nets have weights on the bottom of them that bring them all the way down to the ocean bottom, and then that way you're getting everything in that water column. Well, what happens is they're coming along, they're scraping all the coral and the things that are on the bottom that have made their home there, and they're basically scraping over those and just really destroying them, which is again a problem because a lot of diversity happens again at the bottom of the marine ecosystem. Invasive species. So we talked about that in our case study. The perch there, the Nile perch, but we're also looking at other invasive species, and those are species that literally have came in. They're not normally here. What they do is they call them invasive because they're literally coming in out competing the other native species that have been here forever, and they're taking over. So they disrupt and degrade whole ecosystems by basically out competing the native species there in their ecosystem. A couple examples of the book likes to talk about, especially in the aquatic side, are the water hyacinth, which is in Lake Victoria. That's another one that which also was tampered with in Lake Victoria. The Asian swamp eel, which is really taking over the waters of South Florida. Purple loosestrife, that's a huge one in Michigan. We've had it, especially that inhabits wetlands. It's indigenous to Europe, but brought over because it looked pretty in people's ponds in their backyards, and it spread all throughout the wetlands. So one of the ideas that they had was treating it with a natural predator, a weevil species, and a leaf-eating beetle. Will it work? They don't quite know yet, but there's some tests going on with that. Purple loosestrife. I don't have any pictures of it in my PowerPoint, but very pretty. Take a look at it, look it up, and if you show me a picture of it on your phone, I'll give you a bonus stamp. So it's the first person to do that gets a bonus stamp tomorrow. But purple loosestrife, one of those very pretty species, but also very invasive. It can outcompete native cattail species in inland wetlands. This is what a water hyacinth looks like. That's a boat, by the way. I know it looks kind of crazy. That's a boat right there, and literally you can see all of this different habitat. It basically looks like a field of grass, but really those are aquatic emergent plants that are just floating on top of the water. The science focus. So how have the carp have muddied some waters? In Lake Wingra, Wisconsin, a very eutrophic lake, which I talked about what the word eutrophic meant in Chapter 8, also contains lots of invasive species. The purple loosestrife are there, the common carp that are actually probably brought from Asian waters, but not the Asian carp that we'll talk about in the video, but very similar. But those have all, really done a number on muddying the water of Lake Wingra. Dr. Richard Lathrop was a research biologist that basically he said, let's take a look and see if we remove those invasive species, if the ecosystem can rebound or repair itself. And if you look at the picture on the next slide here, it definitely works. So he literally fenced off in a fence that stretched all the way down to the bottom, took out every carp he could find, removed all the purple loosestrife from the coastline, and literally this ecosystem, just in this, has rebounded itself to become more oligotrophic. You see the water clarity is totally different. So very interesting that ecosystems can rebound if we can get rid of those invasive species. But the problem is very hard to get rid of invasive species overall. That's the name invasive. Population's growth and pollution can reduce aquatic biodiversity as well. We talk about this a lot. When nitrates and phosphates, from fertilizers run off into water, this leads to algal blooms, which causes major eutrophication. It's not just eutrophication; it's cultural eutrophication. And toxic pollutants entering from industrial areas and urban areas can also have a major problem and disrupt ecosystems. Climate change is also a growing threat as global warming continues. As scientists think, sea levels they expect will rise and aquatic biodiversity will then be threatened. We talked about in Chapter 8 the coral reefs and how they're being bleached by this process. Some swamp and low-lying islands will literally be covered over with water, and it will drown many highly productive coastal wetlands, like, for instance, in Louisiana. We looked at that last chapter in Chapter 8 with that 1 meter 1 meter in raise of water, the water level. All right, so science focus, protecting and restoring mangroves, the mangrove forest. We talked about this as being a key ecosystem, a type of marine ecosystem that literally helps reduce major impacts on the shoreline. And it's done that for hundreds of thousands of years, and so it's important that we protect that species because it protects us from tropical storms and tsunamis and coastal erosion. It's way cheaper than building concrete seawalls and levees and things like that. And the mangrove forests are all in Indonesia. And we know, from a few years back in 2005, the Asian tsunami that really did some damage there because of us tampering with those mangrove forests. So the trick is to replant mangroves. Stop wasting our time building concrete walls and replant native habitat that really does a better job than our man-made stuff to begin with. Overfishing is another problem that's happening it's another threat that is upon the marine ecosystem as well as freshwater. It says gone fishing, fish gone. This is the title of this slide, but it is true. The marine and freshwater fish have been threatened with extinction by many human activities, not just fishing. And there's some other vocabulary I want you to learn from this, and one of those is called commercial extinction. That's where the fish species, or the target species that's being fished, is really no longer profitable to fish those species because the numbers are so far down. It's hard to find them. You're using manpower, long hours, lots of equipment to try to find that species. It eventually becomes where there's no profit to be made, and that becomes commercially extinct. This is a great example of the collapse of the cod fishery of the Atlantic coast. That's a big one. We'll talk about that in just a second. But bycatch is another term I want you to know. That is basically when you are fishing with big nets, the species that you are not trying to catch, the ones that you're not targeting to eat or harvest, is what we call bycatch. And that could be sea turtles, sharks, bottlenose dolphins, whales, a number of different things that you're just not trying to catch. And they, depending on your fishing methods, they can lose their life, which is bad for the bulk of the different species, or they can just become entangled in nets and cause fishermen problems as well. This is just a look back at, let's go jump back to that cod fishery off the Canadian coast. And I don't know if you know this, but a lot of your fish sticks that you I'm sure some of you like fish sticks, I like fish sticks, but a lot of our fish sticks used to be out of cod, and it was taken from this fishery. But this is back in the day, back in the 90s, and I really liked fish sticks when I was younger, and all that good stuff. And by 92, the fisheries, at least off the Canadian coast, were basically none. They become commercially extinct as far as the fishery itself. It did rise a little bit after fishing stopped there, but again, super low numbers, nothing to where it was back in the 1970s. So that was a huge collapse. So now if you check your fish sticks box, a majority of them are not made out of cod anymore. So check it out. And actually, if you can tell me, another bonus stamp, if you can tell me which type of fish most fish sticks are made of today, I'll give you a bonus stamp and bring some proof with you. All right? All right, case study. Let's take a look at industrial fish harvesting. Big business. I mean, everyone loves seafood. I know we love it here on the eastern coast of North Carolina. But let's take a look at our four main fishing methods, and there's four of them. First one is trawler fishing, which we talked about a little bit before. A big net kind of following a boat, scrape along the bottom, getting the whole water column, collecting as many fish as it possibly can. The second one is purse seining. And it's very similar, but the net lays on the bottom, and all of a sudden it gets pulled up, and whatever is directly above that net gets caught in the net. Another one is long lining, where basically it's a huge long or rope of different hooks with different baits attached to them, and it's catching whatever fish. Well, I guess it could be the same bait if you're targeting one fish, but it's basically catching a lot of fish on a lot of hooks on one line. And the last one is drift net fishing, where you're basically sitting a net in a water column. It has certain mesh holes in it, and the fish swim into it, and they get their head stuck in it. They can't swim back out, so they get caught. You bring it up, and they're already dead for you for the most part. This is just a picture of looking at all those different commercial fishing methods. Again, we talked about purse seining. The net lays at the bottom. It's pulled up, catches whatever is above it. You have trawler fishing, a big net following along, trying to get as much of the water column as it can. This boat's actually using sonar to detect where the big fish schools are as well. Fish farming in a cage. You can actually farm fish off the coast in large cages and feed them. There's the long lining with the amount of hooks and the fish attached to them. You can even do deep sea aquaculture for bigger fish like tuna and things like that. So you're keeping them trapped in a net, feeding them on a regular basis, but just kind of keep them offshore. Just kind of a couple of different types of fishing methods since you're controlling that a little bit better. And then obviously drift netting, literally throwing a net line out, letting those fish get caught in it. Their gills get caught, you pull the line in, now you have fish. And even some people actually use spotter planes depending on the fishing company that you're working with, and they'll actually go ahead and look up top and look down and survey and see where are those big dark shadows of schools of fish are for you to target with your nets. So those are just a different couple of types of fishing methods. And that brings us to the end of 11.1. See you next time.